Guys, welcome back to the channel. Today I'm walking you through building a complete vector storage solution step by step. First, we'll set up Supabase for vector storage from scratch. Then I'll show you how to vectorize documents and store them into Supabase using n8n. Finally, we'll be leveling up by adding metadata to make your vectors more powerful and more searchable. By then, you'll have a fully functional AI document searching system. So let's get started. Okay, so before we get into the video, let me explain what a vector database actually is. So a vector database is a specialized type of database designed to store and search through vectors. And vectors are essentially a list of numbers that represent the meaning or characteristics of data like text, images, or audio files. So think of it this way. Imagine you wanted to organize a massive library, but instead of sorting the books alphabetically, you organize them by how similar their content and themes are. Books about cooking would be clustered together, mystery novels will be in another section, and science textbooks in yet another section. A vector database does something similar, but with any type of data. Here's how it works in practice. When you feed text into an AI system, it converts that text into a vector, basically a unique fingerprint of numbers that captures the meaning. For example, the sentences, "the dog is running" and "a canine is jogging" would have very similar vectors because they mean roughly the same thing, even though they use different words. Vector databases excel at something called similarity search. Instead of looking for exact matches like traditional databases, they can find items that are conceptually similar. So if you search for pet care, let's say, the vector database might return results about dog grooming or cat health, even if those exact words weren't in your search. This is incredibly useful for AI applications because it enables features like chatbots that can understand context and provide relevant answers, recommendation systems that suggest similar products, or search engines that understand what you mean rather than just matching keywords. The AI can quickly find the most relevant information from vast amounts of data, making interactions feel more natural and intelligent. The key advantage is speed and relevance. Vector databases can search through millions of pieces of information in milliseconds and return results based on meaning rather than just keyword matching. I hope you understood that. Okay, so first we're going to learn how to vectorize a document without metadata. And I'll show you guys how to set up Supabase and download a file from Google Drive. So let's first upload the video to Google Drive. Not the video, the PDF file, I'm sorry. So I'm going to be using the F1 regulations for this. Okay, not this image. There. Okay, I'm going to wait for that to upload. Okay, as we can see, it's in YouTube, the YouTube folder. Then we'll go back to here, open this file from list. Now we can see here from list, and select the file. And you see it popped up. There's two of them because I already have another one uploaded. So just click on that. So this will actually download the actual PDF. So I'm going to execute that step to show you what actually is outputted from this. So execute step. Now, as we can see, it outputted data, file name F1 regulations, .pdf, the file extension is a PDF, MIME type is a PDF. So this is a binary file, and we can't import a binary file into Supabase. So we have to extract all the text from that file and then import that text into Supabase. So that's where this node comes in, the extract from file node. So you do extract from PDF or whatever file you're using. And then, so this is the input binary field name, this orange name, whatever this orange is, you would put that here in the input binary field. And then we're going to execute this step. Okay, so as we can see here, we go into table, we can see the text. And as we can see, this is the whole PDF right here. Now we're going to actually need to import this into Supabase. So before we do that, let's set up a Supabase account. And I'll show you guys how to connect with their API and where to find the API keys and actually how to set up a database in Supabase. So first, you go to Supabase and create an account and go to your projects, and then create a new project and host it in the server closest to you. So I already did that, and then you would open that project, you go into project settings, you go to API keys, and then you go into here, click here and add new credential. So the host would be, you'd find the host in general. Sorry, the host would be here in data API. So this is the host URL. You just copy this, put that here, then you go to API keys, copy the server secret role, copy that, paste it here, save it and see if okay, it says credentials successfully tested. So that means it worked. Now we're connected here. And then I'm just gonna refresh this. We actually need to create a table where this information would be imported. So you would want to go to SQL editor, go to quick starts, click on LangChain. This is for AI. And then you'll see this code here, but you don't really need to understand. You just click this green button here, run. Now it's running. Okay, success, no rows returned. If that pops up, that means you did it correctly. Then you go to database. It would load the tables, and here's your database. Now, if you want to rename the database, you go into here where it says create table. As you can see, it's saying create table that's called documents. You would change that to whatever you want, and wherever it says documents, except for here, match underscore documents, you would change it to the name you want. So let's go back to tables. Okay. So when you go to database, you click this, open that, and now the table's open. So this is all we need for now. Now to actually embed it, you'd find the table. So as you can see, you go to table name from list, and then table here's documents, and embedding batch size. That means for every 200 characters, it's creating a new batch of text. So every batch of text has 200 characters in it. And then the default data loader.
I can't connect to the Wi-Fi network. You might want to check the connection settings in the Google Home app.
Okay, then in the default data loader, we go into here, type of data JSON, load all input data, text splitting simple. And then you would need to add an embeddings model. I'm using Google Gemini, text embedding 004. And as you can see, the embeddings, the default model is using 768 dimensional embeddings. So for whatever embeddings model you use, you need to have these same dimensions in Supabase when you're creating your table, and I'll show you how to change that right now. So you would do the same thing, LangChain, and then right here you can see embedding vector, and then a number. So I forgot to change mine, so I'll show you guys how to do that. Let me just delete this table. Delete the table. And then you go into SQL editor. Now I'm going to change this here. I'm going to be 768. And then here, 768. I'm going to run that. Now we see we got an error. So if you ever get an error, we can just do debug with assistant, send the assistant a message, and it'll actually debug the error for us and send us the fixed code. So you can see fixed SQL snippet, you just copy that, paste that here, run. As we can see, we got another error. So I'm going to debug that with Assistant. Okay, here we go. No, not bad. Here's the recommended fix. Paste that in here. Now this should work. Okay, success, no rows returned. So yeah, if you're getting any errors, just debug with Assistant and it'll eventually fix it. Now we can go to Table Editor, and the table should show up here. There it is. Okay, so now the dimensions are the same as the embeddings model. So we can go back and actually embed. So let's test that step. Execute. Now you can see here, it's embedding. See, embedded 137 items. Let me just refresh. As you can see here, these are the regulations without metadata. So this would just be embedding without metadata. As you can see here, there's no metadata connected. So this is good if you don't want any like extremely accurate searches in a database. If you want like an FAQ that's a little bit broad, like for pricing or just whatever, or you just don't want it to be super case sensitive and accurate, you would use this way of embedding without metadata. Now let's get into embedding with metadata. Let's go down here, connect that here. So now we're going to be doing the same thing, downloading the file, F1 regulations, extracting from file, and then actually creating this code. So what this code does is I'll open the document and show you guys. So let's open this. So what this code does is it will add metadata from each rule to the end of that rule. So it would add metadata from F3.1.1 all the way down to F3.1.2 and then add a new metadata tag starting from that new rule. So basically F3.1 will be connected to this text, F3.1.2 will be connected to this text, and so on and so forth. So you would just go to Claude, go into Claude and say, write me a n8n JavaScript code node that will add a metadata tag for each rule, starting from a rule number to the start of the next rule number. And that's how this code would be made. And you can just keep debugging if it's not giving the right output. But I'll have this in my Discord server in the description. You can join to download these workflows. Also, it's like a networking community. I'm trying to get as many entrepreneurs and AI enthusiasts in there to network and just thrive in that community. So if you would like to join, it's in the description below. So let's go on with this. And then here, you would have the table name. So I'm going to go to my Supabase account, Supabase account 2 that I just made, embed into that table. Now, we don't want to embed into this table because it's already populated. So I'm going to show you guys how to make a new table. You just go to SQL editor. You're going to do quick starts, LangChain, and then I'm going to call this one documents underscore 2. So let's see, everywhere where it says documents. So here it says documents.embedding, do documents underscore 2 embedding from documents underscore 2. Then here you would put underscore 2 again. So you can see what you need to change. Now, put the embedding vector as the one that your embeddings model uses. So I'll do 768 since I'm using Google Gemini, but I think ChatGPT uses 1536 embedding dimensions. So let's run this and see if it works. Okay, vector already exists. Let's just debug that with the assistant. Okay, update a script. Let's try this now. Run. Okay, success now was returned. He's going to table editor. See if it shows up. There we go. Documents _2. Now going to n8n. I'm gonna refresh this list. As you see, documents _2 pops up, embedding bat size 200. Now, I'm gonna show you guys why this is different. So first, let's download the file. Okay, extract from file. So you see it extracted the text. And then this code node, here I'll show you, execute step, F1 regulation number F1. So this is the actual metadata, regulation underscore number. Now, here, you would add metadata. So I'll actually go through that with you guys. Click here, metadata, add property, name. I'm gonna call mine regulation number. And then the value would be regulation underscore number or whatever you output it as. Put that here. So this will basically just add the regulation number metadata to each text chunk that is related to it. And then we would just set up Supabase the same as usual. So let's execute this workflow again. Download the file. Extract from file code. Now see it's loading with metadata, as you can see. There we go, 636 items embedded. Now let's see here. Okay, as we can see, it's way more cleaner and split up. Okay, so this beginning is just like a table of contents, so that really doesn't matter. Now here where the rules start. So as you can see, I'm gonna go back here. As we can see, so F3.2.7 contains this, and it also contains F3.2.8, and it's just a huge mess. Now we would go in, let's go into actual the rules. And it's just a huge mess. So F1.9 goes here, then it stops. As we can see, it stops here at used for, then it continues here for what it's used for. So the AI would have a hard time actually figuring out that this is connected to F1.9. It probably could, but it wouldn't be as accurate. It wouldn't be as consistent and accurate. So let's go back to the same rule here. F1.9. I'm gonna have to load more rows. Just refresh that. Go to the next page. Okay. And so as we can see, let's go to rule F 2.4. As we can see, f2.4 is here, and then the continuation of that rule is here, here. But I think this is just a table of context for now. Let's go to this page. Okay, here's f1.9. Here it is. f1.9 starts here. Requirements is the following. So this, everything in the f1.8, f1.9 is down here. I'll actually go to that to show you exactly the difference. So f1.9 will be up here. Let me just find this. Yeah, f1.9, it started in the, right before, at the end here. So it starts here, f1.9. As we can see, it has the regulation number, f1.9, f5.1.9. So we go here, go to the top, and you see here, it has the same regulation number, f5.1.9, and then f5.1.9. And that's the full rule. This also has f1.9, and then f1 regulations, also, and then f22 has regulation number f22, and it goes down here, all the way to f5.2. You can see f5.2 has regulation number f5.2. So this makes the search, database search that the AI does extremely accurate. And that basically wraps up the video. If you guys want to download this, it'll be in the Discord server below. And if you want to network with like-minded people, also join the Discord server. I'm trying to create a big community for AI creators and just entrepreneurs as a whole. And if you need any custom AI solutions for your business or AI workflows, you can email me or go to my website, agentifiedai.net, or you can message me directly on Discord. Thanks for watching. If this helped, make sure to like and subscribe. See you guys in the next video.